Alright guys, so the first video we're going to do today is on transformations of linear equations. Before we start, I want to do a quick reminder of the best way to learn from a video, because we're going to be doing a lot of them given our circumstances. So remember, you should be listening, actually listening to my voice, not closed caption, like actually listen to what I'm saying. You should be writing things down, and you should also be watching what I'm doing. So those three things are super important. Now, this particular lesson, you might be able to completely do the questions without my help, especially if you already did the Desmos activity and that seemed to make sense to you. Then a lot of these questions you might really understand. So, but I'm just going to guide you through. Now, I also know that a lot of you don't have printers at home, which is totally fine. You can still do this without a printer. You just want to take notes on your own paper. So in order to do that, you want to make sure that you're putting numbers and you're writing down the answers to your questions. You don't necessarily have to write the question unless it's an actual problem, right? So if I'm saying like graph y equals x plus 5, then maybe write down y equals x plus 5. But the first question where it says if you graph a line and then change its y-intercept to a higher value, what happens to the line? Then you don't necessarily have to write that question down. Okay, so I do encourage you at this point to stop the video and at least read the first 4 questions and see if you can answer them, and then come right back and make sure you've got it. All right, so the first 2 questions are about the y-intercept. So remember, I just want to remind you that we're talking about equations in slope-intercept form right now. So reminder that the equation y equals mx plus b is slope-intercept form. And the b, remember, is your y-intercept. So I want you to just think about that for a second. If I have a line, right, and I say the equation is y equals x plus 1. Let's just think about that. The y-intercept is 1, right? So we would start around 1, and then my slope is 1, right? So I'm going to go up 1 over 1. So I'm going to end up having this line like this. Now if I have an equation that says like y equals x minus 4, well here you would start the line at negative 4, like around here, and it still has a slope of 1. So it would still be looking like that. So if you think about it, when you're moving your y-intercept, like let's say if my y-intercept was negative 3, it would be here. If it was 4, it would be way up here, right? So when you're moving your y-intercept around, what you're doing is you're shifting the line either up or down, because it's the y-intercept, right? So the higher the y-intercept, the higher up you're shifting it. So in this one, you would say that the line is shifted up, or goes up. And then if it's going to a lower value, the line is shifted down. So think about that. Remember, the y-axis goes up and down. So if you are changing the y-intercept, you're moving the whole line up and down, and all the points on that line are going up and down based on the y-intercept. Now these next 2 questions are asking if you change the slope to a higher value, what happens to the line? And if you change the slope to a lower value, what happens to the line? I should be a little bit more specific, and what I'm actually talking about is the absolute value of the line. And we'll talk more about why I'm talking about absolute value here in a minute. Well, when you change the slope, well, the slope is your steepness of the line, right? So the higher the value of the slope, the steeper the slope is going to get. So here the line gets steeper. And then if you're going to a smaller value, the line gets less steep or flatter. So the line gets less steep, or you might hear me say it gets flatter, right? So if you need a visual for that, let's just say that if I have a line that's like y equals 5x plus 1, right? Just a quick reminder of graphing something like that. Well, 5x plus 1, well, the y-intercept would be about here, and then you're rising 5 running 1. So you're going up 1, 2, 3, 4, 5 over 1. Or you're going down 1, 2, 3, 4, 5 over 1, right? So it gets really steep, right? But if I say like y equals 1/5 x plus 1, well, here, y-intercept's still 1. I'm going to go down 1 to the right 5, right? Or up 1 to the left 5, right? So the line is actually going to be a whole lot less steep. Does that make sense? All right, let's move on to the next set of questions. So typically, we compare our lines to the parent function. Every single function has a parent function. And when you get into Algebra 2, you'll really talk a lot about all the different functions. In Algebra 1, we only talk about lines and parabolas, quadratic equations, which we're going to get into next. So the parent function is a line that has a slope of 1 and passes through the origin. The equation is y equals 1x plus 0, or really, the equation is just y equals x. And so when you go to graph y equals x, reminder, the slope is the coefficient of x, which is 1, right? And the y-intercept, since there isn't one, would be 0, 0. So here, if I graph this, my line is going to be, you start at 0, 0, and then you just keep going up 1 over 1, up 1 over 1, or down 1 to the left 1, down 1 to the left 1. And so what you have is this basic line, and it's called the parent function because it is the most basic linear equation that there is. It has the slope of 1 and the origin is 0, 0. So pretty much what we often do is we end up comparing and contrasting other lines to the parent function. So now let's look at the opposite of that. So the opposite of the parent function would be a line that has a slope of -1 and passes through the origin. So that equation would be y equals -1x plus 0, but the simplified version would just be y equals -x. So the slope would be -1, and again, the y-intercept would be 0, 0. So then, again, we would start at 0, 0, but now we're making it negative. So it's going to go down 1 to the right 1, down 1 to the right 1, down 1 to the right 1, or the opposite of down and to the right is up and to the left. So then we have this line that goes in this direction. Now, if we're comparing these two, and I'm asking, well, which one is steeper? Well, we can't actually say which one is steeper because they actually have the same steepness. The only difference is they're going in opposite directions, right? So that's why I said earlier we're talking about the absolute value of the slope. Since the absolute value of both of these slopes is just 1, they have the same steepness. The lines are just going in different directions, right? If you imagine putting a little guy on the top of these lines and skiing down these lines or sledding down these lines, they're going to go the same speed because they're just going in the same direction, or they're just going in opposite directions, but it's the same steepness. Okay, so now let's look at 7 and 8. When the y-intercept of a line is positive, where is the line in relation to the parent function? Well, think about that. The y-intercept of the parent function is 0, 0. So think about any line that's positive. It's going to be anything up here or anything up here. It's going to be above, right? So here we're going to say it's going to be above the parent function. If it's negative, negative would be all the ones, the y-intercepts are all down here, they're all negative. Well, those are going to be below the parent function. Now let's take a look at question number 9. So number 9, it says if you graphed 5 different lines with the same slope but different y-intercepts on the same graph, how would you describe what you would see? So think about that. If I were graphing a bunch of lines that had the same slope, the same rise over the same run, think about what that would be. So like, let's say I've got y equals x plus 1, right? That would be a line like this. Y equals x minus 2. That would be a line like this, right? Y equals x minus 7 would be, the y-intercept would be down here, but if my slope is still 1, or 1/2, or 2/3, or -4/5 or something like that, what's going to be true is that all the lines would be parallel and they would all be above and below each other, right? So if they have the same slope, the lines will be parallel. And they'd shift above and below each other. All right, which leads me now to talking about comparing and contrasting graphs. Now, of course, if this is confusing to you, you can definitely open up Desmos and type in the equations and see what they look like. That sometimes helps. So when I ask you to compare and contrast your graphs, what I'm asking you to do is really look at the slopes and the y-intercepts and tell me what it is, like what you can tell me about these two lines based on the fact that you have the slopes and the y-intercepts of them. So for this one, for both of these equations, if you look at the slopes, both the slopes are 4, right? If I were to graph those, since the slopes are 4, they would be parallel to each other. Now the y-intercepts are different, right? So the y-intercepts would be that the first one would be below the second one, or you could say the second one is going to be above the first one, right? So this one right here is going to be below that one, right? So I'm going to say below, and I'll just write the equation. Let me just scratch that out because my eraser's not really working. Okay, it would be below y equals 4x plus 2. So now the question, will they intersect? Well, here, if you think about what parallel lines do, parallel lines don't intersect, right? So we were going to say no, that they don't intersect, and the reason that we know that is because they have the same slope. Or you could say you know that they're parallel, right? But when two lines have the same slope, they're never going to intersect because the rise over the run is going to be the same. So now the next question is saying, well, how does each equation compare to the parent function? Well, you're going to tell me two things. You're going to say something about the slope, right? Is it going to be steeper or less steep or flatter? Or is it going to be above the line or below the line, right? So the parent function, remember, is y equals x, right? That's going to be that equation, that line that goes right through the center. And you're just going to say, all right, this line, y equals 4x minus 3. Is that going to be more steep or less steep? Well, the slope of this line is 1. The slope of this is 4. Well, 4 is going to be more steep, so it's going to be steeper. And then the y-intercept is negative 3. Well, the y-intercept of the parent function is 0, 0. So it's going to be below, right? So it's going to be steeper and below the parent function. That would be how you would describe that. The next one, y equals 4x plus 2. Well, again, we have a slope of 4, which is the same as the other one, so it's still going to be steeper. But here the y-intercept is positive 2. So think about the y-intercept being up here at positive 2. It's going to be above the parent function. Now stop the video and try number 11 completely on your own and see if you can do it. And then tune back in to see if you've got it right. Okay, so here you go. And these two, they have different slopes and the same y-intercept. So I pointed out that they have the same y-intercept. And then I also wanted to say, okay, since they do have different slopes, one is steeper than the other one, right? So now think about the absolute value of negative 1/2 is 1/2. And the absolute value of negative 3/4 is 3/4. So if you think about this, 1/2 is smaller than 3/4. So this one is going to end up being steeper. So I just said this one is steeper. If you wanted to say this one was flatter or less steep, that's totally fine as well. All right, so yes, they're definitely going to intersect. And the reason we know that they're going to intersect is because they have different slopes. If you even wanted to be more specific, where are they going to intersect? Well, in this case, they're going to intersect at the y-intercept. You won't always be able to tell that from the equation, but just know if they have different slopes, they're definitely going to intersect somewhere. The only way they're not going to intersect is if they have the same slope because they're then parallel. Now here, comparing to the opposite parent function, remember the slope here is negative 1. The absolute value of negative 1 is 1. So when you were comparing the slopes, we're thinking of the absolute values of them. So reminder that a slope of positive 1 and a slope of negative 1 are the same steepness. They're just going in opposite directions. So here, both of these are going to be less steep because 1/2 and 3/4 is smaller than 1. And then they're going to be above the parent function because the y-intercepts are 10. Okay, now stop the video and try problems 12 through 16 completely without me. When you're done, come back and I will explain some of them, you may not have the same answers as me. So in fact, I would expect to see that you get different answers than me on most of them, but something close to what I have, because all you're coming up with is something that's steeper and less steep or between two things. So see if you can come up with equations there. Reminder, steepness, you're dealing with slope, and going above and below something, you are dealing with y-intercept. So stop the video, give it a try. Okay, so for these problems, I haven't put answers in yet. What I've done is I've put stipulations on it. So for question number 12, when you write your equation, I said y equals 3x, but you don't have to have y equals 3x. What you have to have is something where the m value, the coefficient of x, the absolute value of that number has to be bigger than 2. So this number right here, as long as that number, the absolute value of that number is bigger than 2, you did it correctly. For less steep, the absolute value of your coefficient of x has to be less than 2. So as long as this number is less than 2, you're golden, okay? And the next one, I said y equals 2x here. This number has to be greater than 1/2. The absolute value of your slope has to be greater than 1/2. And then the next one, your absolute value has to be less than 1/2. So I would say y equals 1/5 x, okay? For number 14, I ended up writing that y was equal to negative 3x, but your slope here just has to be, this number has to be greater than the absolute value of that number has to be greater than 2, okay? Here, the absolute value of this one has to be greater or less than 2. So I have something like y equals negative 1/2 x, right? So with the negatives, they don't have to be negative, right? I could have positive 1/2 x. That's still going to be less steep. It's just helpful to have them go in the same directions when you're comparing, but it doesn't really matter. So to the next one, write an equation that's parallel. To become parallel, they still have to have the same slope of 3. So no matter what equation you write, they have to have a slope of 3. So you're going to have y equals 3x. And then my y-intercept, I just said minus 6. But this number, what I mean here is that number, the y-intercept, has to be between negative 8 and 3. For the next one, your slope has to be negative 2/3. And the y-intercept has to be between negative 1 and 5. So I could say like +1. All right? All right, so some of these might be frustrating for you because there's multiple answers, but there's stipulations on your answers. So now let's take a look at number 17, 18, and 19. I want you to think through this. What I want is you to come up with 2 equations that these 2 lines could be. So you're comparing and contrasting them, right? You're thinking about, okay, what's true about their slopes? What's true about their y-intercepts? So for example, number 7, we don't have a scale on the x and y axis, but we know that A has a greater, the y-intercept for A is right here. It has a greater y-intercept than the line for B. And if you think about it, A has to have a positive y-intercept and B has to have a negative y-intercept. Now these 2 lines appear to be parallel to me, so they also have a slope that's going to be the same. So a sample answer here could be like y equals x plus 2 for A and y equals x minus, we don't want to say minus 2 because think about the distance from here to here. If I'm saying that's 2, then 2 is probably about there. So that has to be less than negative 2. So I would say maybe like negative 5, right? And I chose a slope of 1 because that looks like it has a slope of 1 to me. But it doesn't matter, right? Like you could say that A was positive 10. That would mean this would be like negative 50, right? And your y-intercept or your slope, depending on what your scale is, your slope could be anything, really, as long as they're the same, you're good. So now stop the video and try 18 and 19 100% on your own. So these are my sample answers. When you're checking your answers, make sure you're paying really close attention that these 2, they both have the same y-intercept. So whatever number you put here, these 2 numbers have to be the same and they have to be negative. right? Because they're below the origin. So they have to be the same and they have to be negative. Now your slopes, my slope here for B is 1 and my slope for A, I said negative 1/4. What's important is that letter A has to have a negative slope because look at the direction it's going in, right? Remember Mr. Slope Guy. Mr. Slope Guy, if you're going from left to right down, that's a negative slope. So whatever slope you put here has to be negative. And I would say that that slope probably has to be a fraction because that is clearly flatter than the parent function or less steep than the parent function. And then for B, to me, that looks like the slope is probably 1, but as long as this slope is positive and it is greater than 1/4 or greater than whatever you put for letter A, then you did it correctly. Okay? So you could have multiple answers here. Everybody could have something slightly different. For number 19, what's important here is that for letter A, whatever slope you put for letter A has to be less steep than the slope for B. So my slope for A, I said was 1/2. My slope for B, I said was 1. As long as these two numbers are, the A is smaller than the B, you're good. And both the slopes have to be positive because they're both going in positive directions. Now your Y-intercepts, they both have to be positive because they are both above the origin. Now I'm also looking at this, it looks like the distance from 0 here, for the distance from here to here, looks pretty similar than the distance from here to here, right? So I'm saying if this is 4, then I'm going to go up about 4 more to get 8. You could be going up about 3 more. I don't know. These numbers should be about double. Like this should be about double than whatever you put here. So like if I put 2 for B as the Y-intercept, then I would put 4 for 8. Or you could even put like 5 or 3, something close, right? But the important thing is that they both have to be positive, and letter B, the Y-intercept, has to be smaller than letter A. All right, so hopefully this is making a little bit more sense. Please let me know if you're stuck on anything, and good luck with the practice.